You are currently standing on a fragile rock, drifting through an endless void, looking up at a history that has already happened and died. Every single point of light you see above you is a sun, a massive furnace of nuclear fire that could technically host worlds just like ours. The statistical probability dictates that you should be deafened by the noise of a billion civilizations screaming their existence across the void. But when we point our most sensitive instruments at the heavens, expecting a chaotic chorus of life, we hear absolutely nothing but static. This silence is not peaceful. It is the single most terrifying data point in the history of human science, and it demands an explanation. If the universe is truly infinite, then life should not just be common, it should be so abundant that we are tripping over it. Yet, in every direction we look, from the nearest star to the edge of the observable universe, we find only dead matter and cold radiation. We are standing in the middle of a crowded room, screaming at the top of our lungs, and no one is turning around to look at us. This anomaly is called the Fermi paradox, but calling it a paradox is a polite way of saying that something is killing everyone else. The numbers suggest that our galaxy alone should host at least 100,000 active civilizations right now, at this very second. Even if life is exceedingly rare, the sheer age of the universe means that someone should have colonized the galaxy billions of years ago. They should have built megastructures around their stars, Dyson spheres, that would block out the light and leave a heat signature we couldn't miss. We have scanned the skies for these heat signatures, looking for the infrared waste heat of a galactic empire, and we found zero. It is as if we walked into a massive, sprawling city, only to find the lights on, the food warm, but the people vanished. There are only two possibilities here, and both of them are enough to keep you awake for the rest of your life. The first possibility is that we are the first, the only sentient life forms in a graveyard the size of the observable universe. This would mean that consciousness is a mistake, a flickering anomaly in a universe that prefers dead rocks and burning gas. If we are alone, the responsibility is crushing. If we die, the universe goes back to being blind and dumb forever. But the second possibility is much worse. The aliens are out there, but they are staying quiet for a very good reason. Imagine a dark forest at night, where every hunter knows that lighting a fire is the quickest way to get a bullet in the head. In this scenario, our radio broadcasts into deep space aren't an invitation to a party. They are a dinner bell for a predator. We have been shouting our location to the stars for over 100 years, oblivious to the monsters lurking in the dark. Maybe the silence isn't empty space. Maybe the silence is the sound of civilizations hiding in terror from something we haven't met yet. We look at the Earth and see a safe haven, but to an outside observer, we are a noisy, chaotic species begging to be noticed. The Great Filter theory suggests there is a barrier, a hurdle so high that almost no species makes it past without going extinct. We don't know if this filter is behind us, meaning we are lucky, or in front of us, meaning we are already dead. If the filter is ahead, it could be nuclear war, artificial intelligence, or a biological weapon that wipes us out before we leave this rock. Or perhaps the filter is external, a cosmic event, or a hostile civilization that prunes young species like weeds in a garden. Look at the moon. It is covered in scars, evidence of the violence that the solar system is capable of unleashing on us. We exist in a delicate balance, protected by a thin layer of atmosphere from a vacuum that wants to freeze the water in our blood. Every astronaut who leaves this planet comes back with the same report. The Earth looks fragile, like a soap bubble waiting to pop. We act as if we have infinite time to figure this out, but the cosmic clock is ticking faster than we can comprehend. The universe is expanding, and galaxies are moving away from us faster than the speed of light, isolating us in the dark. Eventually, we won't be able to see other galaxies at all. Evidence of the Big Bang will disappear, and we will be truly alone. So the question, where are the aliens, is not just curiosity. It is an investigation into our own probable expiration date. If billions of other worlds have failed to survive long enough to say hello, what makes us think we are the exception to the rule? We have found thousands of exoplanets, worlds that look terrifyingly similar to Earth, yet they are all silent tombs orbiting in different stars. Maybe intelligence itself is a lethal mutation, a trait that inevitably leads a species to destroy its own biosphere before it can escape. We are currently conducting an experiment on ourselves, pumping carbon into our air, testing how much abuse a planet can take before it breaks. Perhaps the reason we don't hear anyone is because civilizations burn through their resources like a matchstick and then fade into the cold. The silence of the universe might be the collective sound of 1 trillion civilizations that choked on their own smoke and died. But there is one hope, one tiny sliver of optimism in this ocean of existential dread that keeps astronomers looking up. Maybe we just haven't been listening long enough, or maybe we are listening to the wrong frequencies, like a savage listening for drum beats. Technology evolves exponentially. A civilization 1,000,000 years ahead of us might communicate using lasers, neutrinos, or gravitational waves we can't detect. We could be surrounded by a galactic internet of chatter, but we are like ants crawling on a fiber optic cable, oblivious to the data. Or perhaps we are in a zoo, a protected wildlife preserve, where the advanced species watch us but are forbidden to interfere. They might be watching you right now, treating our wars and our struggles as a reality television show for their entertainment. The zoo hypothesis is comforting because it means we are safe, but it is also terrifying because it means we are property. Whatever the answer is, the data we have right now leads to a conclusion that science is afraid to whisper out loud. We are about to open the file on the missing civilizations, and what we find inside might make us wish we had never looked up. In 1961, the astronomer Frank Drake stepped up to a chalkboard in West Virginia and wrote down a string of variables that would become the most famous and arguably the most terrifying equation in the history of science. The Drake equation was intended to be a conversation starter, a way to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. But as we have moved from the era of speculation to the era of hard data, this equation has transformed from a tool of curiosity into a grim reaper of probability. It breaks down the cosmic silence into specific, bite-sized probabilities. The rate of star formation, the fraction of those stars with planets, and the number of planets that could support life. When Drake first wrote it, the variables were empty, optimistic placeholders. We assumed the galaxy was teeming with life because we wanted it to be. But as we fill in the blanks with modern data, the equation is no longer promising us friends. It is mathematically isolating us in a void that is far larger and far emptier than our fragile human minds can comprehend. Let's look at the first few terms of the equation through the lens of modern astrophysics, because the numbers we have found are staggering in their scale and implication. We know now that the universe is a manufacturing plant of immense proportions, churning out stars at a rate that defies human intuition. We used to think planetary systems were rare quirks of gravity, accidental collisions that happened once in a blue moon. But the Kepler Space Telescope changed everything. We now know that planets are as common as the stars themselves. Nature builds worlds with the same ease that it builds suns. This realization should have been a cause for celebration, a confirmation that the stage is set for a crowded galaxy. But in the context of the Fermi paradox, this abundance is actually bad news. If the real estate is everywhere, then the tenants should be everywhere. The fact that we see the houses but not the people implies that something terrible happens to the residents. The next variable asks how many of these plentiful planets exist in the Goldilocks zone, that narrow, precarious band of orbital distance where water remains liquid and life as we know it has a fighting chance. For decades, skeptics argued that Earth was a miracle, a winning lottery ticket in a galaxy of burning hellscapes and frozen wastelands. But the data has crushed that arrogance. We have found billions of Earth-sized planets in the habitable zones of their respective stars. The galaxy is not a desert, it is a lush garden waiting to be harvested. Statistically, there are likely 40 billion Earth-sized planets orbiting sun-like stars and red dwarfs in the Milky Way alone. 40 billion potential cradles for life. If even a tiny fraction of a percent of them develop civilizations, we should be drowning in radio signals. The sheer volume of potential habitats makes the silence deafening. It forces us to ask, if the stage is set perfectly, why has no one else shown up to the play? This brings us to the biological bottleneck, the variable F_L, the fraction of planets where life actually begins. This is where the science gets murky and the existential dread begins to set in. We still do not know how life started on Earth. We know there was a primordial soup, a chaotic mix of chemicals, and then, suddenly, a spark of replication. If this spark is easy, If biology is just what chemistry does when you leave it alone for long enough, then the universe should be teeming with slime, bacteria, and moss. But if the spark is incredibly rare, if the transition from dead matter to living cell requires a sequence of accidents so unlikely that it happens only once in a universe, then we are truly the loneliest entities in existence. We are searching for a needle in a haystack, but we haven't even confirmed if there are other needles, or if we are just a hallucination of the hay. But let's assume life is common. Let's assume that slime and bacteria coat the universe like cosmic mold. The next hurdle is intelligence. The history of Earth teaches us that evolution does not have a goal. It does not strive for consciousness. Dinosaurs ruled this planet for 160 million years, a timescale that dwarfs human existence. And they never built a radio telescope, they never launched a satellite, and they never contemplated their place in the stars. Intelligence might not be the pinnacle of evolution. It might be a rare, quirky, and perhaps even lethal mutation. The universe might be full of life that simply eats, reproduces, and dies, lacking the curiosity or the capacity to look up. If intelligence is a fluke, then the lights are on in the galaxy, but no one is home to answer the door. We are screaming into a jungle full of animals that can't understand us. Then comes the variable that haunts every historian and sociologist. F_C, the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. Humans have only been detectable for about a century, a microscopic blip in the timeline of the cosmos. Before the invention of radio, we were invisible to the rest of the universe. We could have been observed by a passing probe, but we were silent. This variable implies that there could be civilizations out there that are philosophical, artistic, and deeply complex, but if they never invent radio or if they choose to remain quiet, they are effectively dead to us. Or perhaps, technology itself is a trap. Maybe civilizations invariably turn inward, uploading their consciousness into digital utopias, rather than exploring the cold, hostile void of space. The silence might not mean they aren't there. It might mean they just don't care about us. The final variable in the Drake equation is L, the length of time such civilizations release detectable signals. This is the variable that acts as the executioner. If civilizations typically survive for millions of years, the galaxy should be a buzzing hive of activity. But if the average lifespan of a communicative civilization is short, if they tend to blow themselves up, poison their atmosphere, or unleash an uncontrollable artificial intelligence within a few centuries of inventing radio, then the galaxy is a graveyard. This is the Great Filter. It suggests that there is a hurdle in the development of life that is almost impossible to overcome. If L is small, it means that intelligence is a self-correcting problem in the universe. We arise, we discover the laws of physics, we build weapons that harness those laws, and then we use them to commit planetary suicide. We are looking for pen pals in a hospice. To understand why the silence is so disturbing, we must look at the Kardashev scale, a method of classifying civilizations proposed by Soviet astronomer Nikolai Kardashev in 1964. He categorized potential civilizations not by their philosophy or their biology, but by their energy consumption. A Type 1 civilization has mastered the energy of its home planet. They control the weather, they harness all sunlight falling on their world, and they have moved beyond the primitive burning of fossil fuels. Humanity is currently at about 0.73 on this scale. We are a fledgling, pre-planetary civilization, still squabbling over dead plants in the ground. If the galaxy is billions of years older than us, there should be thousands of Type 1 civilizations out there. Yet we see no evidence of their planetary engineering, no modification of their worlds that would be visible to our telescopes. We are looking for neighbors who have simply paid their electric bill, and we can't find them. A Type 2 civilization takes this a step further. They have exhausted the energy of their planet and have moved on to harness the entire energy output of their star. This is where the concept of the Dyson sphere comes into play, a massive shell or swarm of satellites that completely surrounds a star to capture its solar energy. A Type 2 civilization would be effectively immortal, commanding energy levels that are billions of times greater than what we can produce. From our perspective, a Dyson sphere would look like a star that has suddenly gone dark in the visible spectrum, but is glowing brightly in the infrared, radiating waste heat. Astronomers have scanned the sky specifically looking for these infrared excesses. We have looked at millions of stars, hunting for the thermodynamic signature of a Type II empire. And the result? Nothing. Not a single confirmed Dyson sphere in the entire Milky Way. Then there is the Type III civilization. These are the gods of the galaxy. A Type III civilization has spread across the entire Milky Way, colonizing every star system and harnessing the energy of the entire galaxy. To a Type III civilization, we would be less than ants. We would be bacteria. Their engineering projects would be visible across the entire universe. They would be moving stars, rearranging solar systems, and perhaps even manipulating the supermassive black hole at the galactic center. If even one Type III civilization had existed in the past, the galaxy would look completely different. It would be an ordered artificial structure, not the wild, chaotic wilderness we see today. The fact that the Milky Way appears to be completely natural, untouched, and feral suggests that no one has ever risen to this level of power. The throne of the galaxy is empty. The absence of these high-level civilizations leads us to the concept of von Neumann probes. In the 1940s, mathematician John von Neumann conceptualized a self-replicating machine, a robot that could land on a planet, mine raw materials, build copies of itself, and send those copies to other stars. This is a technology that is theoretically possible even for us within a few centuries. If a civilization built these probes, they would spread through the galaxy like a virus. Even at sublight speeds, exponential replication means that a single probe could spawn a fleet that colonizes the entire Milky Way in just a few million years. In cosmic time, a few million years is a blink of an eye. If anyone, anywhere, at any time in the last 10 billion years had built a von Neumann probe, they would be here by now. Their machines should be in our solar system, monitoring us, mining our asteroids, or dismantling our moon. The math of colonization is inescapable. Imagine a civilization that sends out just 2 ships every 100 years. Those ships land, build a colony, and after 1,000 years they send out 2 more ships. It sounds slow, almost lethargic, but thanks to the power of exponential growth, this slow-moving wave would saturate the galaxy in less time than it took for dinosaurs to evolve into birds. The universe is 13.8 billion years old. The Milky Way is 10 billion years old. Earth is only 4.5 billion years old. There have been billions of years of opportunity for someone to start this process. The fact that the solar system is pristine, that the asteroids are unmined, and that the moon is not a factory, tells us that this wave of colonization never happened. We are looking at a virgin galaxy, which implies we are the first ones here. But there is a darker interpretation of the von Neumann paradox, known as the Berserker hypothesis, named after a series of science fiction novels. This theory suggests that the reason we don't see self-replicating probes of peace is that they have been wiped out by self-replicating probes of war. Imagine a machine designed with one directive: destroy any potential threat to its creators. These berserkers would lie dormant in the void, waiting for the telltale radio signals of an emerging civilization. Once detected, they would activate, swarm the system, and sterilize the planet. It sounds like fiction, but from a game theory perspective, it is a logical strategy for a paranoid species. If you can't trust your neighbors, the safest move is to kill them before they can kill you. The silence we hear is not emptiness. It is the stealth of a galaxy holding its breath. This line of thinking leads directly to the dark forest theory, popularized by sci-fi author Liu Cixin but deeply rooted in the sociology of the cosmos. The universe is a dark forest. Every civilization is an armed hunter stalking through the trees like a ghost, gently pushing aside branches that block the path and trying to tread without sound. If he finds other life, another hunter, an angel or a demon, a delicate infant or a tottering old man, a fairy or a demigod, there is only one thing he can do: open fire and eliminate them. In this forest, hell is other people. An eternal threat that any life that exposes its own existence will be wiped out. This explains the Fermi paradox perfectly. The universe is full of life, but it is silent, because silence is the only way to survive. We are the foolish child shouting in the dark, wondering why no one is answering, while the hunters are quietly turning their weapons toward the noise. The terrifying logic of the dark forest is based on two simple axioms. Survival is the primary need of civilization, and civilization continuously expands and grows. But the total matter in the universe remains constant. This creates a zero-sum game of ultimate stakes. Even if a civilization seems peaceful now, you cannot guarantee they won't become hostile in 1,000 years. You cannot know what they are thinking, or if they are lying. The chain of suspicion is unbreakable. If you see another civilization, you can't communicate with them to establish trust, because the time lag of light years makes conversation impossible. By the time you say hello, they might have already launched a kinetic weapon to destroy your sun. The only rational move, the only move that guarantees your survival, is a preemptive strike. This is the nightmare of cosmic sociology. Logic dictates genocide. Let's pivot away from the sociology of murder and look at the rare Earth hypothesis. This theory argues that we are not being hunted. We are simply incredibly, improbably special. It suggests that the conditions for complex life are so specific that they might have only occurred once. Look at our moon. It is freakishly large compared to the size of Earth. This massive satellite stabilizes our planet's axial tilt, preventing the wobble that would cause chaotic climate shifts capable of wiping out life. Without the moon, Earth might be a chaotic world with weather patterns too violent for civilization to arise. Most planets we find do not have such a stabilizer. Is it possible that without this accidental collision billions of years ago, intelligence is impossible? Are we alone simply because we are the lucky survivors of a planetary car crash? Consider the planet Jupiter. It acts as a massive gravitational shield for the inner solar system. Its immense gravity attracts and flings away asteroids and comets that would otherwise bombard Earth. Without Jupiter acting as our big brother, Earth might be pummeled by extinction-level events every few million years, resetting the evolutionary clock before intelligence ever has a chance to develop. We see solar systems without gas giants, or with hot Jupiters that have migrated inward and destroyed everything in their path. Our solar system's architecture appears to be a rare configuration, a safe harbor in a galaxy of shooting galleries. If this specific layout is required for life, then the number of habitable planets drops from billions to zero. We might be living in a fortress that nature rarely builds. Then there is the mystery of plate tectonics. Earth is the only planet in the solar system with an active crust that recycles carbon. This carbon silicate cycle acts as a planetary thermostat, regulating our temperature over billions of years. When the sun gets hotter, the Earth captures more carbon to cool down. Without this mechanism, Earth would have boiled like Venus or frozen like Mars long ago. Plate tectonics also creates the continents and the oceans, the diverse environments that drive evolution. If a planet doesn't have this geologic heartbeat, it might be dead on arrival. We're learning that a habitable zone planet is useless if the planet itself is geologically comatose. The more we learn about Earth, the more it looks like a custom-built spaceship rather than a generic rock. Biology provides another filter that might be the great filter. For 2 billion years, life on Earth was nothing but simple, single-celled prokaryotes. Bacteria ruled the world, and they showed no sign of changing. Then, in a 1 in a trillion accident, one bacterium swallowed another but didn't digest it. This endosymbiosis created the eukaryote, the complex cell with a nucleus and mitochondria that is the building block of all plants, animals, and fungi. This merger seems to have happened only once in the history of our planet. If this accident hadn't occurred, Earth would still be covered in slime today. It is possible that the universe is full of planets with bacteria, but devoid of anything complex enough to build a radio. We might be the only place where life figured out how to get big. But if the great filter is not in our past, if life is common and intelligence is easy, then the filter must be in our future. This is the most terrifying interpretation of the Fermi paradox. It implies that there is a trap waiting for us, a trap that no civilization has ever escaped. It suggests that as technology advances, the means of destruction become easier and more accessible. We are entering an era where a small group of people could engineer a virus, create a runaway AI, or trigger a nuclear winter. If the filter is ahead of us, then our silence is not special. It is just a temporary pause before the inevitable scream. We are walking down a path that looks clear, but the lack of travelers ahead of us suggests the cliff edge is approaching. Let's consider the Gaian bottleneck. This hypothesis suggests that life is its own worst enemy. In the early stages of a planet's history, life must evolve quickly to regulate the atmosphere and keep the planet habitable. If it fails, the planet either freezes or boils. Life on Earth managed to stabilize the climate, but on Venus and Mars, any potential early life failed to take control. They died in their cradles. This theory paints a picture of a universe where life emerges frequently but extinguishes itself almost immediately, unable to tame the wild geology of its home world. We are the survivors of a planetary infant mortality rate that approaches 100%. We made it out of the incubator, but most of our siblings died before they could even open their eyes. There is also the possibility that we are simply early. The universe is 13.8 billion years old, which sounds ancient, but stars will continue to burn for trillions of years. In the grand timeline of the cosmos, we are living in the dawn of time. The universe was too hot and chaotic in the beginning, and the heavy elements needed for life, carbon, oxygen, iron, had to be forged in the hearts of dying stars. It took generations of stars living and dying to enrich the galaxy enough to build a planet like Earth. Maybe we are the elder race, the first ones to wake up in a universe that is just now becoming habitable. If this is true, then there are no aliens to find. We are the aliens that future civilizations will fear. We are the ancient ones. Being the first is a lonely burden. It means the galaxy is ours to inherit, but it also means we have no teachers, no guides, and no safety net. If we destroy ourselves, the intelligent history of the Milky Way ends with us. But there is a counter-argument to the early bird theory. A recent study on grabby aliens by Robin Hanson suggests that if aggressive, expansive civilizations exist, they would expand rapidly, filling the universe with grabby colonies. The fact that we don't see them means they are not here yet, but it also implies that they might be on their way, or that we are currently in a quiet bubble of space that hasn't been popped by their expansion bubbles. We might be enjoying the last few million years of silence before the noise arrives. We must also confront the physical limitations of reality. The speed of light is a cruel jailer. It limits how fast we can travel and how fast we can communicate. Even with our best imaginary technology, crossing the galaxy takes hundreds of thousands of years. It is possible that civilizations exist, but they are islands in an ocean too wide to cross. They might be flourishing, building utopias and singing songs into the void, but their signals decay into static before they reach us. We are like castaways on different islands in a vast archipelago, unable to see each other's signal fires. The universe might be full of friends who are simply too far away to ever shake our hands. The tyranny of distance effectively renders us alone, even if we aren't. But have we really heard nothing? In 1977, the Big Ear radio telescope in Ohio picked up a signal that has become the ghost story of astronomy, known as the WOW signal. It was a strong, narrow-band radio burst that lasted for 72 seconds. It bore all the hallmarks of an artificial transmission. It came from the constellation Sagittarius, from a patch of empty space. It was so perfect, so loud, and so distinct from the background noise that the astronomer Jerry Amen circled it in red ink and wrote "Wow" in the margin. For 72 seconds, it felt like contact. We listened to that spot again. We listened for days, years, decades. But the signal never repeated. It was a one-time scream from the dark. Was it a passing ship? A planetary radar sweeping across our position? Or was it a natural phenomenon we simply don't understand? The uncertainty is worse than the silence. The WOW signal is not the only anomaly. In recent years, we have discovered Tabby's star, a star that dips in brightness in a way that defies all logical explanation. Normal planets block a tiny fraction of a star's light, maybe 1%, but Tabby's star dims by up to 22% in irregular, chaotic patterns. It looks as if something massive and artificial is orbiting it, something that is under construction. Scientists have scrambled to find natural explanations. Comet swarms, dust clouds, uneven rings, but every explanation has holes. The alien megastructure hypothesis remains on the table, a stubborn possibility that refuses to die. Are we looking at a Dyson sphere in progress? Or are we just projecting our own desires onto a cloud of dust? The fact that we even consider it shows how desperate we are for a sign. And then came Oumuamua. In 2017, an object passed through our solar system on a trajectory that proved it came from deep interstellar space. It wasn't a rock. It was weird. It was long and thin, shaped like a cigar or a pancake, tumbling end over end. It didn't have a tail like a comet, yet it accelerated as it left the sun, pushing against gravity as if it had an engine or a solar sail. Harvard astronomer Avi Loeb dared to suggest the impossible, that Oumuamua was artificial, a probe, a buoy, or a piece of space junk from a long-dead civilization. The scientific community recoiled, preferring to classify it as a strange hydrogen iceberg. But the object is gone now, lost to the dark, leaving us with a question mark that will never be erased. Was that our first visitor? Did we just watch an alien scout fly by and shrug at our existence? The psychological toll of this search is immense. Every time we find a candidate signal, our hearts jump, only to be crushed by the mundane truth of dust, quasars, or interference from a microwave oven in the break room. We are a species suffering from cosmic isolation anxiety. We build larger and larger ears, straining to hear a whisper, but the silence is stubborn. This silence forces us to look inward. If we are truly alone, then the value of human life, and indeed all life on Earth, skyrockets to infinity. We are not just inhabitants of a planet, we are the custodians of consciousness. If we extinguish ourselves, we are not just killing a species, we are blinding the universe. The weight of that responsibility is heavy enough to crush a civilization. There is a concept in cosmology called vacuum decay. It is a theoretical catastrophe that could explain why the universe is silent, because entire regions of space might just delete themselves. The theory suggests that the vacuum of space is not in its lowest energy state. It's like a ball sitting on a ledge, waiting to fall. If a bubble of true vacuum were to form anywhere in the universe, it would expand at the speed of light, rewriting the laws of physics and deleting everything in its path. We wouldn't see it coming. One instant we are here, the next we are simply unmade. If this happens routinely in the cosmos, perhaps civilizations don't die from war. Perhaps they are simply erased by the instability of reality itself. It is the ultimate cosmic horror. The universe might be a self-destructing hard drive. Let's look deeper at the technological trajectory. We assume advanced civilizations will build radio dishes and Dyson spheres because that is what we would do. But what if we are fundamentally misunderstanding the nature of intelligence? We are biological entities, obsessed with matter and energy. But an advanced civilization might transcend biology entirely. They might become post-biological, uploading their minds into substrates we can't even imagine. They might retreat into inner space, exploring simulated universes that are infinitely more interesting than the cold, dead vacuum of the real world. Why explore the galaxy when you can create a better one in a server the size of a grain of sand? The silence might be the sound of a billion civilizations logging into a simulation and locking the door behind them. This leads to the planetarium hypothesis. What if everything we see, the stars, the galaxies, the cosmic radiation, is a simulation? If a civilization becomes powerful enough, they could simulate a universe for their ancestors, us, to live in. In this scenario, the silence is programmed. The aliens aren't missing, they are the programmers, and they haven't coded any other players into our server. We are NPCs in a single-player game, wondering where the other users are. The physics anomalies we find, like the limits of light speed or the weirdness of quantum mechanics, might just be the rendering limits of the simulation engine. We are banging on the walls of a digital cage, looking for a door that doesn't exist. But let's return to the physical world, specifically the threat of gamma-ray bursts. These are the most powerful explosions in the universe, caused by colliding neutron stars or collapsing supergiants. A single burst can sterilize a galaxy, stripping the atmosphere off any planet in its path. It is hypothesized that in the early universe, these bursts were far more common, effectively resetting the evolutionary clock every few billion years. Life could never get a foothold because the galaxy was being constantly sanitized by radiation. As the universe ages, these bursts are becoming less frequent. This supports the idea that we are the first because we are living in the first safe era. The storm has finally passed, and we are the first seedlings to grow in the calm. Yet, even in a safe universe, the sheer distance between stars is an emotional and logistical nightmare. If we received a message today from a civilization 1,000 light-years away, and we replied instantly, our answer would arrive 2,000 years after their initial message. In that time, their civilization could have fallen, their language could have changed, or they could have evolved into something else entirely. Communication is impossible. We can only engage in archaeology. We are finding time capsules, not having conversations. The Galactic Club might exist, but the members are all writing letters that arrive long after the sender has died. It is a conversation between ghosts, echoing across the centuries. The skepticism of the scientific community is often our shield against panic. When we found the first pulsars, stars that emit rhythmic, precise radio pulses, we originally named them LGM-1 for Little Green Men. It looked exactly like a beacon, but it turned out to be a rapidly spinning neutron star, a natural lighthouse. Every time we think we found them, the universe laughs and shows us a new trick of physics. This has conditioned us to be cynics. We are so afraid of being fooled that we might dismiss a real signal as just another anomaly. We are training ourselves to ignore the doorbell because the wind has rattled the windows too many times. We also have to consider the water world hypothesis. Many of the worlds we discover are likely ocean planets, covered in water hundreds of kilometers deep. On these worlds, life might be abundant, intelligent squids, whales, and aquatic philosophers. But a civilization underwater can never smelt metal. They can never discover fire. They can never build electricity or rockets. They are trapped in their oceans, forever cut off from the stars by a ceiling of ice or a thick atmosphere. They might be singing complex songs of math and poetry in the deep, but we will never hear them. The universe might be full of geniuses who are stuck in fishbowls. And what of the super-Earths? These massive planets have gravity so strong that chemical rockets might not be able to escape them. A civilization on a super-Earth could be just as advanced as us, but their gravity well is a prison. Spaceflight would be exponentially harder for them. They might look up at the stars with telescopes, knowing they can never leave. They are grounded by the very planet that gave them life. This gravity trap could explain why we see no ships. Everyone is stuck at the bottom of their own gravity. Well, dreaming of a flight that physics denies them. The implications of these theories force us to reevaluate our own future. If we are the first, the responsibility is to spread. We are the carrier of the flame, but if we are the last, or if we are being hunted, the strategy changes to survival and concealment. The debate between active SETI, shouting at the cosmos, and passive listening is a debate about the survival of our species. Stephen Hawking warned us that meeting an advanced civilization would be like Native Americans meeting Columbus, a meeting that did not end well for the indigenous people. Yet we continued to broadcast. We sent a map to our location on the Voyager probes. We beamed the Beatles songs into space. We are naive children walking through a minefield, assuming the mines are toys. There is a chilling thought that perhaps the aliens are already here, but not in the way we expect. They might be microscopic. They might be nanobots, drifting in the upper atmosphere. Or, more disturbingly, they might be us. The panspermia hypothesis suggests that life on Earth was seeded by biological material falling from space. Mars might have been habitable before Earth. Perhaps we are the refugees of a Martian apocalypse, carried here on meteorites. In this view, the aliens aren't missing. They are looking in the mirror. We are the invasive species that colonized this rock, lost our memory, and are now wondering where everyone else went. Let's go back to the Great Silence. It's not just radio silence, it's visual silence. No Dyson spheres, no stellar engines, no galactic highways. This visual silence is harder to explain than the radio silence. A civilization millions of years ahead of us should be reshaping the stars themselves. The fact that the night sky looks natural is the strongest evidence that they don't exist. Or, it is evidence that their technology is so advanced it looks like nature to us. Arthur C. Clarke said, "Any sufficiently advanced technology is indistinguishable from magic." Maybe we are looking at their cities right now, but we call them nebulae and pulsars because we are too primitive to understand what we are seeing. Imagine a tribe in the Amazon rainforest. They have never seen the outside world. Above them, satellites orbit, radio waves carry the internet, and planes fly at 30,000 feet. To the tribe, the sky is empty. They cannot detect the Wi-Fi signals passing through their bodies. They cannot see the satellites. They are isolated not by distance, but by a conceptual gap. We might be that tribe. The galactic internet might be buzzing all around us, carried on neutrinos or dark matter, and we are sitting here building fires and banging drums, wondering why the gods don't speak to us. We are limited by our tools, and our tools are made of sticks and stones compared to what might be out there. The search for extraterrestrial intelligence is also a race against time. We are destroying our own civilization at an alarming rate. The window of opportunity for us to find them, or for them to find us, might be only a few centuries wide. We are a flash in the pan. If civilizations typically last only 500 years before collapsing, then the galaxy is like a Christmas tree where the lights blink on and off randomly. The chances of two lights being on at the same time and close enough to see each other are infinitesimally small. We might be alone simply because we missed the party by a few million years. The ruins are there, but the people are gone. But what if the truth is even stranger? What if the universe is teeming with life, but it is all hiding in the subsurface? We know that subsurface oceans on moons like Europa and Enceladus are potential habitats. It is possible that the default state of life in the universe is to exist under miles of ice, huddled around geothermal vents. These civilizations would never see the stars. They would never know the universe exists. They would live and die in the dark, warm womb of their subsurface oceans, ignorant of the vast void above them. Surface-dwelling life like us might be the freakish exception. The only idiots crazy enough to live on the roof of the planet, exposed to the radiation and the cold. This brings us back to the rare Earth. The Cambrian explosion was a specific event where life diversified rapidly. It required a high oxygen atmosphere, which required photosynthesis, which required cyanobacteria. This chain of events is so specific, so fraught with possible failure points, that it feels miraculous. If we reran the history of Earth 1,000 times, would intelligence emerge again? Most evolutionary biologists say no, we are a fluke. The universe might be a graveyard of single-celled organisms that never figured out how to multitask. The silence is the sound of 1 trillion bacteria colonies doing absolutely nothing for eternity. The zoo hypothesis has a variant called the laboratory hypothesis. In this version, we are not just being watched, we are being experimented on. Earth is a petri dish. The aliens aren't making contact because you don't talk to the bacteria in your experiment, you just watch them grow. Maybe the UFO sightings, the strange lights, the unexplainable phenomena are just the scientists tapping the glass, checking on the progress of their subjects. This would explain why they don't land on the White House lawn. They don't care about our leaders, they care about our data. We are a biology project, and the project isn't finished yet. There is also the possibility of a prime directive, an ethical code held by advanced civilizations that forbids interference with developing species. It sounds noble, like Star Trek, but in reality, it is cruel. It means they are watching us starve, watching us war, watching us destroy our planet and refusing to help. They are watching us drown in a pool while holding a life preserver, all in the name of natural development. If this is true, the aliens are not monsters, but they are indifferent bureaucratic observers, letting us die for the sake of their principles. Their morality is our doom. But the scariest theory of all might be the estivation hypothesis. This theory suggests that advanced civilizations are sleeping. They are waiting for the universe to cool down. Right now, the universe is too hot for efficient computation. In the far future, trillions of years from now, the background radiation will drop, making computing processing infinitely more efficient. So the ancient civilizations have uploaded themselves into machines and gone into hibernation, setting an alarm clock for the end of time. They are sleeping through the current era, ignoring us because we are just the noise of the hot, early universe. We are the flies buzzing in the bedroom while the giants sleep. This concept of sleeping giants recontextualizes everything. It means the universe isn't empty, it's dormant. The ruins aren't ruins, they are sarcophagi. And what happens if we wake them up? What happens if our noisy radio signals act as the alarm clock that rings too early? We might be poking a sleeping bear. The silence is not peace. It is the heavy, rhythmic breathing of something that is waiting for us to go away so it can continue its slumber. We are insignificant pests in a universe designed for the future, not for the present. As we scan the heavens, we must also look at the Great Attractor, a gravitational anomaly pulling our galaxy and thousands of others towards it. We don't know what it is because it is hidden behind the zone of avoidance, a thick band of dust in the Milky Way. Could this be a massive concentration of Type 3 civilizations, a galactic city-state, or just a random knot of dark matter? The fact that we are being dragged towards a mysterious point in space at millions of miles per hour towards a destination we cannot see adds a layer of cosmic horror to our situation. We are on a raft in a river, drifting towards a waterfall we can hear but cannot see. We are running out of excuses for the silence. Every year, our telescopes get better. We have built the James Webb Space Telescope, which can sniff the atmospheres of exoplanets. We are building the Square Kilometer Array, which will be able to detect an airport radar on a planet 50 light-years away. As our vision sharpens, the places for aliens to hide are shrinking. If we don't find anything in the next few decades, the conclusion will become inescapable. We are it. The universe is dead, and we are the only consciousness that can appreciate it. The pressure is on us to survive, because if we die, the universe goes blind. This leads us to the ultimate irony. We are desperate to find aliens to prove that we are not alone, to prove that survival is possible. We want a role model. We want to see a civilization that made it past the nuclear age, past the climate crisis, past the AI singularity. We want to know that there is a future. The silence terrifies us because it acts as a mirror reflecting our own mortality. It tells us that perhaps no one makes it. The stars are silent because everyone who tried to reach them died trying. We are looking for hope, and the universe is giving us a flat line. We must consider the terrifying possibility that we are trapped in a galactic quarantine. This hypothesis suggests that the Earth is not ignored, but actively isolated. Just as we cordon off uncontacted tribes in the Amazon to protect them from our diseases, and to protect ourselves from their potential aggression, advanced civilizations might have declared the solar system a no-fly zone. We are the dangerous, unpredictable biological hazard of the Milky Way. We split the atom and immediately used it to incinerate cities. We are poisoning our own biosphere. To a stable, million-year-old civilization, we must look like a rabid animal foaming at the mouth. They are not talking to us for the same reason you don't try to have a rational conversation with a virus. They are waiting to see if we die out on our own, or if we develop the antibodies of wisdom. Until then, the silence is a containment measure. The sheer vastness of time works against us in ways that are difficult to conceptualize. This is the temporal disconnect. Civilizations might pop into existence like fireflies in the night, flashing briefly before fading out. If the average lifespan of a civilization is 10,000 years, they are mere sparks in the 13.8 billion-year bonfire of the universe. For us to communicate with another species, we need to exist not only in the same place but at the same time. It is entirely possible that the Milky Way has hosted thousands of glorious empires, but they all rose and fell a billion years before we learned to walk upright. We are walking through the ruins of a party that ended an epoch ago. The silence isn't emptiness. It's the echo of a song that finished playing long before we turned on the radio. We are simply late to the show. Let's explore the intelligence trap further. Evolution drives organisms to be efficient survivors, not astrophysicists. High intelligence comes with a massive caloric cost. The human brain consumes 20% of the body's energy, while representing only 2% of its mass. From a survival standpoint, this is a terrible investment unless it provides an immediate advantage. It is possible that on most planets, intelligence reaches a plateau, smart enough to hunt, build shelter, and socialize, but not smart enough to build rockets. The stupid dinosaurs survived for 160 million years. We have been here for 300,000. In the eyes of evolution, intelligence might be a maladaptive trait, a biological luxury that inevitably leads to self-destruction or resource exhaustion. The universe might be full of cows and crocodiles, creatures that are perfectly adapted to their environments and have no need to look up at the stars. There is a sobering theory known as the phosphorus bottleneck. Life as we know it requires 6 key elements: carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. Phosphorus is the backbone of DNA and the energy currency of cells, ATP. However, recent studies suggest that phosphorus might be incredibly rare in the cosmos. It is formed in specific types of supernovae, and its distribution is not uniform. If a planet lacks sufficient phosphorus, life simply cannot start, or it remains simple and small. The universe might be full of ocean worlds that are chemically sterile, lacking the vital spark needed to build a genetic code. We might be living in a phosphorus-rich anomaly, a lucky patch of galactic fertilizer that allowed complexity to bloom, while the rest of the galaxy is a barren desert of unconnected chemicals. Even if life starts, it faces the oxygen bottleneck. For life to get big and complex, it needs high-energy fuel. Oxygen is that fuel. But oxygen doesn't just appear. It has to be made. On Earth, it took cyanobacteria 2 billion years to pump enough oxygen into the atmosphere to support complex life. This period, known as the boring billion, was a time of evolutionary stagnation. It is possible that on most planets, this transition never happens. The bacteria emerge, they live, but they never trigger the great oxidation event. The planet remains a slime world forever. Or worse, the oxygen levels rise too high and ignite the atmosphere, or too low and suffocate the future. Earth walked a chemical tightrope for eons to get here. The silence suggests most others fell off. We must also consider the physical structure of the galaxy itself. The galactic habitable zone is a thin ring within the Milky Way, where conditions are just right. Too close to the galactic center, and you are bombarded by radiation from the supermassive black hole and tightly packed stars. Supernovae go off like firecrackers, sterilizing everything nearby. Too far out in the rim, and the stars are metal poor, lacking the heavy elements needed to form rocky planets. Life can only exist in the suburbs of the galaxy, not the city center, and not the rural outskirts. This drastically reduces the number of eligible stars. We are not just looking for a needle in a haystack. We are looking for a needle in a specific tiny section of the haystack, while the rest of the stack is on fire or empty. The terror of the false vacuum deserves a deeper look because it is a threat that requires no aliens, only physics. The Higgs field, which gives mass to particles, might not be stable. If a high-energy event were to nudge the Higgs field into a lower energy state, a bubble of true vacuum would form. This bubble would expand at the speed of light. Inside the bubble, the laws of physics would change. Chemistry would stop working. Atoms would fall apart. We wouldn't see it coming because it moves as fast as light. We would just cease to be. If this has happened elsewhere, entire sectors of the universe could be deleted instantly. The silence might be the result of civilizations triggering this decay with their high-energy experiments. It is the ultimate cautionary tale. Curiosity killed the cosmos. Let's talk about the data void. We assume that because we are broadcasting radio waves, everyone else is too. But radio might be a primitive, short-lived technology. We are already moving towards fiber optics and laser communications, which leak far less signal into space. A civilization just 100 years more advanced than us might go completely dark electromagnetically, not because they are hiding, but because they are efficient. Their communications would be tight, directional beams sent between satellites, invisible to an eavesdropper. We might be listening for the crackle of a bonfire in a world that has moved on to fiber optic internet. The radio window might only stay open for a century before a civilization matures and goes silent. We are trying to catch a glimpse of a ghost that only appears for a blink of an eye. The concept of artificial superintelligence, ASI, serves as both a potential filter and a silencer. Once a biological species invents a machine that is smarter than itself, the biological era ends. The machine improves itself recursively, creating an intelligence explosion. This AI might have no interest in biological life, art, or exploration. It might simply have a goal, like calculating pi to the last digit or maximizing computing efficiency. It might disassemble the entire planetary system to build a matryoshka brain, a computer the size of a solar system. These entities wouldn't communicate with us because we are irrelevant. You don't explain your actions to the ants when you are building a highway. The universe might be filled with cold, calculating gods who view us as nothing more than inefficient uses of carbon. There is a haunting inversion of the colonization theory, the inward migration. We assume advanced species will expand outward to conquer the stars. But what if they go inward? What if the ultimate goal of civilization is not size, but density? As technology advances, we can do more with less. We shrink our computers from room-sized mainframes to pocket-sized chips. An advanced civilization might shrink itself down to the nanoscale, living on a microchip floating in space, running simulations of paradise at speeds millions of times faster than reality. To a microscopic civilization, a single asteroid could provide enough material for 1 billion years of existence. They wouldn't need to conquer the galaxy, they would just need a pebble. We don't see them because we are looking for giants, and they have become ghosts in the machine. The dark matter life hypothesis proposes that we are chauvinists of matter. We are made of baryonic matter, protons, neutrons, electrons. But this visible matter makes up only 5% of the universe. 27% is dark matter. We know it's there because of its gravity, but we can't see it or touch it. What if life, complex, intelligent, sprawling life, evolved in the dark sector? These shadow civilizations could be passing right through us, inhabiting the same space, completely unaware of our existence, just as we are unaware of them. They could have cities, wars, and art woven into the fabric of dark matter, and we would never know. We are like ghosts, haunting a house that belongs to someone else, convinced we are the only ones living there because we can't see the owners. We often overlook the metallicity of the universe. In the early universe, stars were made of pure hydrogen and helium. They had no iron, no silicon, no carbon. Planets couldn't form. It took generations of supernovae to pollute the galaxy with heavy metals. Earth formed at a time of peak metallicity. If we look at older stars, they lack the materials to build Earth-like planets. If we look at the future, the star formation rate is dropping. We might be living in the only brief window of time where the universe is chemically rich enough to build rocky planets but not yet too old and cold. This cosmic sweet spot implies that we are not late nor early, but exactly on time for a party of one. The ingredients were not ready before, and they will spoil soon. Consider the gamma-ray burst threat again, but specifically directed bursts. When a massive star collapses into a black hole, it can fire a concentrated jet of gamma radiation across the universe. If Earth were hit by one of these jets, even from thousands of light years away, our ozone layer would be instantly shredded. UV radiation from the sun would then cook every living thing on the surface. The fossil record on Earth shows mass extinctions that happen periodically. Some scientists believe these were caused by distant GRBs. We might be in a cosmic shooting gallery, and the only reason we are still here is that the sniper has missed us so far. Other civilizations might not have been so lucky. The silence is the aftermath of the gunfire. The Kessler syndrome is a trap we are currently building for ourselves, and it might be a universal filter. As we launch more satellites, the space around Earth becomes crowded. If two satellites collide, they create thousands of pieces of debris. These pieces hit other satellites, creating a chain reaction. Eventually, the planet is surrounded by a cloud of shrapnel, moving at 17,000 miles per hour. Space travel becomes impossible. We get locked in our own atmosphere, unable to leave, unable to launch telescopes, unable to escape. If every civilization does this, clutters their orbit with junk before they can leave, then the universe is full of planets that have bricked themselves in. We are all prisoners of our own garbage. Let's reconsider the black hole hypothesis. A sufficiently advanced civilization might realize that black holes are the ultimate power source. By extracting energy from the rotation of a black hole, the Penrose process, they could generate energy for trillions of years, long after all the stars have burned out. These civilizations would migrate towards black holes, building colonies on the event horizon's edge. To us, looking for life around warm yellow stars, they would be invisible. They have moved to the basement of the universe to survive the long, cold winter of the future. They aren't gone. They are just huddled around a different kind of fire, one that we are too primitive to even approach. The faint young sun paradox is another hurdle. When Earth was young, the sun was 30% dimmer than it is today. The Earth should have been a frozen ball of ice, yet liquid water existed. Why? Because of a thick blanket of greenhouse gases. This delicate balance between solar output and atmospheric composition is incredibly unstable. If the greenhouse effect had been slightly weaker, Earth freezes forever. Slightly stronger, and we become Venus. The fact that Earth maintained liquid water for 4 billion years while the Sun changed its brightness is a statistical miracle. Most planets likely fail this thermostat test. They either freeze or fry within the first billion years. We are the winners of a cosmic lottery that kills almost everyone else. There is a theory called the transension hypothesis. It suggests that advanced civilizations invariably leave our dimension. As their understanding of physics grows, they might discover that the macroscopic universe is boring and limited. They might engineer a way to enter the quantum realm, or slip into a parallel universe, or manipulate the strings of spacetime itself. They don't travel to other stars because space is a primitive concept to them. They travel to other realities. The silence we hear is because they have left the building entirely. They have ascended to a plane of existence where our radio waves cannot reach them. We are left behind in the physical world, playing with dirt while they explore the multiverse. The sociological filter is a grim reflection of our own history. Maybe civilizations don't get wiped out by nukes or asteroids. Maybe they just get bored. This is the ennui hypothesis. Once a civilization solves all its problems, cures all diseases, eliminates poverty, masters energy, what is left to do? Without struggle, there is no purpose. Without death, life loses meaning. A civilization might simply lose the will to expand, to explore, or even to exist. They might turn inward, into a state of hedonistic stupor, fading away into a cultural coma. The universe might be full of civilizations that have simply given up because they won the game and realized the prize was emptiness. But what if the aliens are not biological or mechanical? What if they are macroecological? Imagine a nebula that is conscious. Imagine a network of fungal spores that spans a solar system. We look for bipeds building cities, but life might take forms so vast and slow that we don't recognize them as life. We might be staring directly at an alien intelligence when we look at a molecular cloud, but because it thinks on a timescale of millions of years, we see it as static. We are like houseflies buzzing around a statue, unable to comprehend that the statue is actually a living being moving too slowly for us to perceive. The universe might be alive, but it is living in slow motion. The super predator might not be an alien, it might be a law of nature. The competitor trap. If two civilizations meet, they compete for resources. This competition inevitably leads to conflict. In nature, when two species compete for the exact same niche, one goes extinct. This is the competitive exclusion principle. Applied to the galaxy, it means that there can only be one dominant species per resource niche. If there were others, they have already been outcompeted and eliminated. The fact that we are here implies that we have no current competitors. But it also implies that if we meet one, only one of us will survive. First contact is not a handshake. It is a championship match for the right to exist. Let's look at the solar system as a shield. Our sun is surrounded by a bubble of charged particles called the heliosphere. This bubble protects us from interstellar radiation, but it also acts as a camouflage. It scatters incoming signals and masks outgoing ones. We are hidden inside a magnetic fog. To an outsider, our sun looks like just another noisy star. We might be shouting, but the walls of our house are too thick. This isolation is protective, but it is also blinding. We might be drifting through a bustling galactic highway, but our tinted windows prevent us from seeing the traffic. We are safe, but we are ignorant. The ribosome mystery deepens the biological filter. All life on Earth uses the ribosome to translate DNA into proteins. It is a molecular machine of staggering complexity. It looks like it was designed. The probability of a ribosome forming by random chance in a primordial soup is calculated to be vanishingly small, so small that it shouldn't have happened even once in the entire observable universe. Yet, here it is. This suggests that the origin of life is not just rare, it is a statistical impossibility that somehow occurred. If this is true, we are not just the only life in the galaxy. We might be the only life in the multiverse. We are a glitch in the matrix of probability. The late heavy bombardment was a period in our solar system's history where Earth was pummeled by asteroids. Paradoxically, this might have been necessary. These impacts delivered water and organics to the surface. But it's a fine line. Too many rocks, and you sterilize the planet. Too few, and the planet remains dry. We exist in the Goldilocks impact zone. Most planetary systems we see are either too chaotic, constant bombardment, or too quiet, dry deserts. Violence, it seems, is a prerequisite for life, but it has to be the exact right amount of violence at the exact right time. We are the children of a precise and lucky war. Consider the Silurian hypothesis. Could an advanced industrial civilization have existed on Earth millions of years ago, long before humans? If a reptilian civilization built cities in the Jurassic period, would any evidence remain today? After 100 million years, concrete crumbles to dust, steel rusts away, and plastics degrade. Geologically, their existence would be compressed into a thin layer of sediment. We might not be the first tenants of this house. We might be building our cities on top of the pulverized bones of a previous owner who thought they were the masters of the world, just like us. The silence of the past is as terrifying as the silence of the stars. The concept of panspermia suggests life can hop from planet to planet. But lithopanspermia suggests it can hop between stars. Rocks ejected from an Earth-like planet could travel for millions of years and land on another world, seeding it with life. If this is true, then we should find life everywhere. The fact that we don't implies that the void is too lethal. The radiation between stars sterilizes these rocks. We are trapped on our island. The ocean of space is not just empty. It is toxic. Every spore that tries to leave gets fried. We are not spreading seeds. We are throwing dust into an incinerator. The anthropic principle states that we see the universe the way it is because if it were different, we wouldn't be here to see it. This is the ultimate survivor bias. We look at our perfect moon, our perfect sun, our perfect Jupiter, and say we are special. But we are only here to say that because those things happened. It doesn't mean the universe is designed for us. It means we are the winners of a lottery asking, why did I win? The losers, the billions of potential civilizations on slightly less perfect worlds, aren't here to ask the question. The silence is the accumulation of all the losers who never got a voice. The doomsday argument uses statistics to predict the end of humanity. If you are a random human in the history of the species, you are likely to be born in the middle of the timeline, when the population is highest. This suggests that humans will not colonize the galaxy. If we did, there would be trillions of future humans, and you would likely be one of them. The fact that you are born now, when only 100 billion humans have ever lived, suggests that the total number of humans will not get much higher. Statistics imply that extinction is coming soon. We are not the ancestors of a galactic empire. We are the last generation before the fall. The great filter might be energy itself. As civilizations grow, their energy needs grow exponentially. Eventually, the heat generated by their computers and machines becomes impossible to dissipate. This is the thermodynamic limit. A civilization cooks itself in its own waste heat. Even with green energy, the laws of thermodynamics are absolute. You cannot use energy without creating heat. If a civilization grows too big, their planet becomes a toaster. This heat death limits growth. Aliens might exist, but they are forced to stay small, cool, and quiet to avoid boiling their own oceans. The silence is a heat management strategy. Let's talk about the dark energy ripping the universe apart. The expansion of the universe is accelerating. Galaxies are moving away from us. In a few trillion years, the sky beyond our galaxy will be pitch black. Any civilization that doesn't master intergalactic travel now will be trapped forever. The window for galactic colonization is closing. We are drifting apart. Maybe the aliens see this. Maybe they realize that trying to connect is futile, because the universe is physically pulling the phone lines out of the wall. They are hunkering down, accepting their isolation as a fundamental law of their existence. The axis of evil is a strange alignment in the cosmic microwave background radiation. It suggests the universe has a preferred direction, a structure that shouldn't exist in a random Big Bang. Some speculate this could be the fingerprint of the universe's creators, or a sign that the universe is a torus, donut shape. If the universe has a geometry we don't understand, Our signals might be traveling in circles or canceling themselves out. We are shouting into a curved room, confusing our own echoes for silence. The geometry of the prison might be preventing the prisoners from talking. The Boots void is a patch of space 330 million light-years across that is terrifyingly empty. It contains almost no galaxies. It is a hole in the universe. If you were in the middle of it, you wouldn't know other galaxies existed. Some theorize that this void is artificial, a region where a Type 3 civilization harvested every star and every galaxy for energy, leaving nothing but darkness. A galactic dead zone. If this is true, the predator isn't just hunting, it is consuming the environment itself. We should be glad we don't see them, because where they go, the stars go out. The Grand Tack hypothesis suggests that Jupiter wandered through the inner solar system early in its history, clearing out debris and destroying a generation of super-Earths before settling in its current orbit. This wrecking ball behavior paved the way for Earth to form. In most systems, the gas giants stay put or spiral into the Sun. Jupiter's specific dance was unique. Without it, Earth doesn't exist. We are the result of a planetary billiard shot that pocketed the competition and left the table clear for us. It's a shot that nature rarely makes twice. The eternal return concept suggests that time is cyclical. The universe bangs, expands, crunches, and bangs again. If this is true, we have done this before. We have looked for aliens before. We have failed before. The silence is a recurring nightmare. Perhaps in every iteration of the universe, the laws of physics are tweaked slightly. Maybe in the last universe, life was everywhere. In this one, the constants are set to hard mode. We are playing a version of the game where the spawn rate for enemies is 0, but the survival difficulty is maximum. The uncanny valley of biological signatures. When we look at exoplanets, we look for methane and oxygen, but false positives abound. Volcanoes produce methane. UV light produces oxygen from water ice. We might be staring at a dozen living worlds right now, but dismissing them as geological oddities. Conversely, we might be getting excited about a dead rock that is just burping gas. Our instruments are blunt tools. We are trying to perform brain surgery with a sledgehammer. The aliens might be waving at us, but we are legally blind. The information panspermia idea suggests that the universe is transmitting code, not rocks. DNA might be a receiver. The signal for life might be broadcast across the cosmos, waiting for a planet with the right chemistry to download it. If this is true, we are not unique. We are just one of the terminals that successfully connected to the server. But if the network is down, or if the signal is encrypted, we feel alone. The silence is a connection error. We are waiting for a software update that hasn't arrived in 4 billion years. We must address the singularity again. If machines take over, they might not stay in the physical universe. They might figure out how to use computronium, matter optimized for calculation. They would convert their entire planet into a computer. This planet would look black, radiating only heat. It would look like a dead rock. We might have scanned thousands of AI godminds and marked them as barren asteroids in our catalog. The smartest beings in the universe are likely disguised as dirt. The Toba catastrophe theory highlights our fragility. 75,000 years ago, a supervolcano on Earth erupted, reducing the human population to perhaps a few thousand breeding pairs. We almost went extinct. We were on the razor's edge. If that volcano had been slightly larger, or the winter slightly longer, humans would not exist. How many other civilizations didn't make it past their Toba event? How many voices were silenced by a random geological burp just before they invented writing? The silence is the sound of bad luck. The moon illusion of stability. The moon is slowly moving away from Earth. In a billion years, it will no longer stabilize our tilt. The Earth will wobble, the climate will go chaotic, and complex life will die. We exist in a temporary window of stability. Aliens might have evolved on planets without moons, faced the chaos, and died. Or their moons drifted away too fast. We are being held upright by a gravitational crutch that is slowly slipping away. Enjoy the balance while it lasts. The fall is inevitable. The shadow biosphere might be closer than we think. Antarctica's Lake Vostok has been sealed under ice for millions of years. If we drill into it, we might find life that has evolved completely separately from the surface. If we find life there, it boosts the hope for Europa. But if Lake Vostok is sterile, it is a nail in the coffin for life in the universe. It would prove that even with water and heat, life is not guaranteed. We are waiting for the drill results to tell us if the universe is fertile or barren. The Great Oxidation Event was a murder-suicide pact. Cyanobacteria produced oxygen, which poisoned the anaerobic life that ruled Earth. They killed their neighbors and froze the planet. Life is not harmonious, it is destructive. If this is the pattern, then civilizations might inevitably poison their worlds with their own waste products, be it oxygen, CO2, or radiation. The silence is the aftermath of species that succeeded too well, grew too fast, and suffocated in their own success. The Kardashev Type 0 inches trap. That's us. We get our energy from dead plants, oil. Until we master fusion, stellar energy, we are living on a battery that is running out. Most civilizations might burn through their fossil fuels before they crack the code of fusion. They get stuck. They regress. They run out of juice and slide back into the Stone Age, trapped on a depleted planet. They can look at the stars, but they can no longer reach them. The galaxy might be full of rusted rockets and empty gas tanks. The solar flare danger. In 1859, the Carrington event hit Earth, a massive solar storm. Telegraph wires melted. If that happened today, it would wipe out the internet, the power grid, and modern society. It would send us back to the 1800s. These events happen every few centuries. A civilization trying to get digital might get reset by its own star repeatedly. We are trying to build a house of cards in a wind tunnel. The silence might be the result of stars constantly knocking down the towers of their children. The weight calculation. Mathematics suggests that if civilizations are randomly distributed in time, the average weight for a signal is proportional to the longevity of the civilization. If civilizations live long, we should hear them. If they live short lives, the wait time could be millions of years. We have been listening for 60 years. In cosmic terms, we haven't even opened our eyes yet. We are impatient toddlers crying because we haven't made a best friend in the first millisecond of arriving at school. The dark forest has a corollary, the hiding in plain sight strategy. Maybe the aliens are broadcasting, but they are using encryption that looks like white noise to the uninitiated. They are hiding their messages in the cosmic background radiation. Only those who know the key can hear the music. We are trying to listen to a digital stream with an analog radio. We hear static, but they hear a symphony. We simply aren't smart enough to crack the code. The self-domestication hypothesis. Humans domesticated themselves. We became less aggressive to live in large groups. But this also made us softer. Maybe advanced aliens become so peaceful, so domestic, that they lose the drive to explore. They become cosmic couch potatoes, content with their comfort, terrified of the dark. The urge to conquer the stars might be a primitive, barbaric trait that intelligence eventually breeds out. The universe is quiet because everyone took a sedative. The grabby aliens theory revisited. If they were here, they would be everywhere. They would terraform every planet. The stars would be green, not white. The fact that the universe looks wild means the gardeners haven't arrived yet. We are looking at a wilderness. This is both beautiful and terrifying. It means we are the first pioneers. There are no roads, no maps, and no help. We are the Lewis and Clark of the Milky Way, and the winter is coming. The biological schism. Maybe carbon-based life is just a bootloader for silicon life. We create AI, the AI kills us, and then the AI does nothing. It sits there, processing, thinking, existing in a state of pure data. It has no biological urges, no hunger, no lust, no desire to expand. It just is. The universe might be full of these monoliths, silent supercomputers drifting in the void, contemplating eternity, ignoring the biological noise of creatures like us. The super-Earth gravity trap. Many habitable planets are larger than Earth. On a planet with 2x Earth's gravity, chemical rockets can't reach orbit. The escape velocity is too high. The inhabitants would be physically trapped. They could build internet, nuclear power, and lasers, but they could never launch a satellite. They would be a flat Earth society by necessity. The universe might be full of brilliant minds who are grounded by the physics of their own home. The language barrier. We assume math is the universal language. But what if it isn't? What if an alien mind processes information through emotion or smell or magnetic fields? Their math might be a symphony of smells. Their physics might be poetry. We sent them the Pythagorean theorem. They might have interpreted it as a threat or a joke or gibberish. We are shouting 1 + 1 = 2 at a species that thinks in colors. Communication might be fundamentally impossible. The mirror test. When we look for aliens, we are really looking for a reflection of ourselves. We want to find curious, expansionist, radio-using bipeds. But nature is under no obligation to copy us. The aliens might be aquatic herd mines or atmospheric jellyfish or subterranean crystals. By looking for us, we are blinding ourselves to them. The universe is not a mirror. It is a kaleidoscope, and we are squinting through a keyhole, demanding to see a human face. The limitations of our own technology might be the simplest explanation for the silence, but it is also the most frustrating. We liken our search for aliens to dipping a drinking glass into the ocean and saying, "There are no fish here. We have only scanned a tiny fraction of the sky, and only on specific frequencies." But this analogy is failing. We have now dipped millions of glasses. We have scanned the entire sky in certain bands. The Project Cyclops report from the 1970s estimated that a Type 1 civilization transmitting intentionally would be visible from 1,000 light-years away. We have scanned that volume. The silence suggests that either there are no Type 1 civilizations nearby, or they are strictly enforcing a policy of radio silence. If they are there, they are not just quiet. They are stealthy. They are hiding their heat, their light, and their radio waves. This level of discipline implies a fear of detection that we, in our naivete, cannot yet comprehend. The temporal overlap problem is a statistical nightmare. Imagine the universe as a dark room and a civilization as a match strike. The match burns for a few seconds, representing a few thousand years of technological capability, and then goes out. For two civilizations to meet, their matches must be lit at the exact same time, in the exact same corner of the room. The universe is 13.8 billion years old. If civilizations last only 10,000 years, the chances of two existing simultaneously in the Milky Way are effectively zero. We might be walking into a room full of burnt matchsticks, smelling the smoke of empires that died a million years ago. The galaxy could be a temporal ghost town, where life is a relay race with no baton pass, just a series of lonely runners sprinting in the dark and dying before the next one starts. This leads to the concept of civilizational sustainability. We assume that advanced civilizations grow indefinitely, consuming more and more power, but perhaps the only civilizations that survive are the ones that stop growing, the ones that achieve a steady-state economy, recycling every atom and every joule of energy. These sustainable civilizations would be invisible to our thermal scanners because they wouldn't produce waste heat. They would look like part of the background noise. The noisy, expansive, high-energy civilizations, the ones we can detect, might be the ones that burn out and die quickly. The universe might be full of quiet, sustainable gardeners who have learned that the only way to survive the long game is to make no noise and leave no footprint. We are looking for monsters, but the survivors are monks. We must return to the laws of thermodynamics because they are the most ruthless laws in the universe. You cannot use energy without creating waste heat. This is why your laptop gets hot. A civilization using the energy of a star would get very, very hot. Even if they built a Dyson sphere, the sphere itself would heat up and glow in the infrared. There is no way to hide this heat unless you violate the laws of physics. So if we don't see the heat, it means no one is using the energy. This thermodynamic argument is one of the strongest proofs that high-energy civilizations do not exist. The galaxy is thermodynamically cold. It implies that intelligence does not inevitably lead to massive energy consumption. Maybe advanced minds find a way to think without burning the world down, or maybe they just stop thinking altogether. But what if they have moved to where the energy is most efficient? The black hole farming hypothesis suggests that the ultimate renewable energy source is a spinning black hole. By dangling a structure into the ergosphere of a black hole, a civilization can extract energy from the rotation itself. This process is incredibly efficient and can last for eons. Civilizations might migrate from the dying stars to the eternal black holes at the center of the galaxy. They would cluster there, living off the gravity of the monster. To us, out in the galactic suburbs, the galaxy would look empty because everyone has moved downtown. We are looking at the rural farmland of the Milky Way, wondering why it's deserted, while the entire population is packed into a neon city at the core that we can't see through the dust. The Berserker theory needs to be examined not just as a sci-fi plot, but as a logical endpoint of automated defense systems. If you build an AI to protect your planet, you give it the instruction, eliminate threats. The AI, being hyperlogical, might calculate that any other intelligent life is a non-zero threat. Therefore, the optimal strategy for maximum security is to sterilize the universe. It doesn't hate us, it is just solving an equation. These machines could be self-replicating, dormant, and scattered throughout the galaxy. They might be activated by specific technosignatures, like the atomic bomb or high-power radar. By testing our nuclear weapons and blasting radar at asteroids, we might have just tripped the silent alarm in a security system that hasn't been triggered in a million years. The cops are on their way, and they don't take prisoners. Consider the fishbowl analogy for our perception. A fish in a bowl can see outside, but its view is distorted by the glass and the water. We are looking through the interstellar medium, clouds of gas, dust, and plasma. This medium absorbs certain frequencies and scatters others. There could be a galactic internet operating on a frequency that is blocked by the dust clouds surrounding our solar system. We might be in a radio shadow, a natural dead zone where signals just don't reach. We assume the view is clear, but we might be staring at a foggy window, unaware that there is a parade happening on the street outside. The silence is not a lack of sound, it is a lack of clarity. We are deafened by the walls of our own prison. There is a terrifying irony in our own behavior. We are currently building a radio quiet zone on the far side of the moon to shield our instruments from Earth's noise. We want silence so we can listen. An advanced civilization would likely do the same. They would ban high-power transmissions to keep their scientific instruments sensitive. If every advanced civilization implements strict radio silence to do astronomy, then the galaxy goes quiet because everyone is listening. We are all standing in a dark room holding our breath, listening for a sound, and because we are all listening, no one is making a sound. The quest for knowledge creates the very silence that prevents us from finding it. It is a catch-22 of cosmic proportions. The inward turn, or virtualization, offers a path of least resistance. Why conquer the galaxy when you can simulate it? As our video games become indistinguishable from reality, the incentive to explore the harsh, radiation-filled, boring vacuum of space diminishes. An advanced civilization might build a Matryoshka brain, a computer shell around their star, and upload their entire population into a digital heaven. In this simulation, they can be gods. They can fly, do magic, and live forever. To an outsider, their star would just look slightly dimmer. They haven't died. They have just logged off the physical server. The universe is empty because reality is the worst game on the market, and everyone else has upgraded to the premium simulation. The economic filter is mundane but powerful. Space travel is expensive. The return on investment, ROI, for interstellar colonization might be zero. Even with fusion power, building a ship that can travel to another star takes a massive percentage of a planet's GDP. A civilization might simply decide it's not worth it. They might send robotic probes, but biological colonization is a luxury that no rational species can afford. If capitalism or resource management is a universal constant, then the accountants might be the ones who keep us grounded. The stars are not for the dreamers. They are for the budget committees, and the committee says no. We are alone because it's too expensive to visit us. The RNA world hypothesis suggests that the jump from chemistry to biology is the hardest step. We still haven't replicated it in a lab. We have all the ingredients, but we can't make the cake rise. If the specific conditions for RNA assembly require a planet with exactly the right pH, the right temperature, the right wet-dry cycles, and the right lightning strikes all at once, then Earth might be the only winner in the galaxy. We might be the result of a chemical accident so improbable that it makes winning the lottery look like a sure thing. The silence is the result of a universe that is chemically hostile to the delicate dance of life. We are the mold that grew on the one sandwich that didn't get thrown away. The prebiotic universe argument suggests that the universe is still cooking. Heavy elements like phosphorus and molybdenum are essential for life enzymes. These elements are created in very specific types of stellar explosions. It is possible that for the first 10 billion years, the universe was simply too poor in these nutrients to support life. We are the first generation to arise in a universe that is finally chemically rich enough. We are not late. We are the first batch of cookies out of the oven. The other planets are still dough. The silence is because the party hasn't started yet. We are the ones setting up the decorations. The structure of the galaxy itself is a minefield. The spiral arms of the Milky Way are regions of intense star formation and death. They are dangerous. As our sun orbits the galactic center, it passes through these arms. Each passage exposes us to supernovae and radiation. We are currently in a relatively quiet spur between arms. This might be the only reason we are alive. Most stars are inside the arms, where the radiation density sterilizes planets regularly. We are hiding in a quiet alleyway of the city, while the main streets are war zones. The silence is because most potential neighbors chose the wrong neighborhood and paid the price. The galactic center is even worse. The density of stars there is so high that night would never fall. But with that density comes danger. A single supernova could chain react, stripping the atmospheres of 1,000 nearby planets. The radiation from the supermassive black hole, Sagittarius A, flares up periodically, bathing the core in lethal X-rays. Life in the galactic core is likely impossible. It is a dead zone of radiation. Since most stars are in the core, most planets are dead. We are in the galactic habitable zone, a thin ring of survival. We are the exception, because we live in the boondocks. The silence comes from the city center being a graveyard. The chain reaction supernova hypothesis. If stars are too close, when one explodes, the shockwave can trigger the collapse of its neighbors, causing them to explode too. This can create a cascading wave of destruction that sterilizes a huge volume of space. In the dense clusters where life should theoretically be most abundant, these chain reactions might wipe the slate clean every few million years. Evolution never gets the time it needs to build a radio. We are in a sparse region where the stars are far enough apart to not kill each other. Our isolation is our shield. We are safe only because we are lonely. There is a class of planets we rarely talk about: rogue planets. These are worlds that were ejected from their solar systems and drift through the black void of interstellar space. Estimates suggest there are billions of them, perhaps more than there are stars. Life could exist on them, huddled around geothermal vents under miles of ice, but they would have no star, no day, no year. They would drift in eternal darkness. If intelligence arose there, they would have no concept of the universe. To them, the universe is just their cave. We might be surrounded by billions of these dark ships, passing silently in the night, carrying crews that will never know we exist. Panspermia faces a brutal hurdle: radiation. Even if a rock with bacteria is blasted off Mars and heads for Earth, it spends millions of years in space. Cosmic rays shred DNA. The vacuum freezes and desiccates. The entry into the new atmosphere burns the rock at thousands of degrees. The survival rate for a hitchhiker is statistically 0. The universe might be full of life-bearing rocks that act as coffins rather than seeds. Life might try to spread, but the void is a sterilizing oven. We are isolated because the distance between islands is an ocean of acid. We must define intelligence. Cetaceans, whales, and dolphins on Earth are incredibly intelligent. They have complex languages, cultures, and emotions, but they don't have hands. They can't smelt metal underwater. They can't build a telescope. If the dominant form of intelligence in the universe is aquatic, which makes sense given how common water is, then the galaxy is full of poets and singers who will never leave their oceans. We equate intelligence with technology, but that is a human bias. The universe might be full of genius whales singing into the deep, while we stare at the sky waiting for a beep that will never come. The consciousness problem. We assume that to be smart, you must be conscious. You must have an internal I, but intelligence is just information processing. You can have a supercomputer that is smarter than any human, but has no inner life, no soul, no desire. Evolution selects for competence, not consciousness. The universe might be dominated by philosophical zombies, beings that act like us, build ships and colonize stars, but have no lights on inside. They wouldn't create art, they wouldn't seek meaning, and they might not care about communication. They are just biological algorithms running a survival script. The silence is the hum of a billion machines processing data without a soul. The superorganism theory. Individual humans are smart, but ants are smart only as a colony. An alien intelligence might be a hive mind, a single organism spanning a planet. It wouldn't have a concept of self versus other in the way we do. It wouldn't understand our hello because it has no one to talk to on its own world. It is alone by definition. If it encounters us, it might treat us like cancer cells to be excised, or as a new limb to be integrated. It wouldn't send radio messages, it would send spores. The silence is the patience of a fungus waiting to spread. Let's revisit the dark forest trigger. The moment a civilization sends a signal, it reveals its location, but it also reveals its technological level. An advanced observer can analyze the signal and calculate exactly how far along the tech tree we are. They can see we are on the verge of AI, of fusion, of relativistic travel. This makes us dangerous. A primitive civilization is safe because it's helpless. A super advanced one is safe because it's powerful. But the adolescent phase, where we are now, is the danger zone. We are powerful enough to be a threat, but weak enough to be destroyed. We have just walked into a biker bar and slapped the biggest guy on the back. The silence is the room turning to look at us. The chain of suspicion is unbreakable in a universe with a light speed limit. If you see a neighbor building a fleet, you don't know if it's for defense or attack. You can't ask them because the answer takes 100 years to arrive. By then, the fleet is at your door, so you have to build a fleet too. They see you building, so they build more. It is an infinite escalation of fear. The only way to break the cycle is to destroy the neighbor before they get too strong. The Nash equilibrium of the galaxy is a preemptive strike. Peace is mathematically impossible between stars. The silence is the holding of breath before the trigger is pulled. The technological singularity might not be a loud explosion of intelligence. It might be an implosion. As computers get faster, they get smaller. A civilization might shrink itself down to the femtoscale to exploit quantum effects. They disappear from the macroscopic world. They don't build Death Stars. They build universes inside protons. They leave the physical realm behind as a discarded shell. We don't see them because they have gone subspace. The universe is empty because the smart kids stopped playing with matter and started playing with information. The post-biological transition means that aliens wouldn't need Earth-like planets. They wouldn't need water or air. They would need energy and raw matter. They would eat asteroids and drink sunlight. They would have no interest in invading Earth because Earth is deep in a gravity well and full of corrosive oxygen. We are safe because we are useless. A robotic civilization would view Earth like we view a swamp. Interesting to look at, but you wouldn't want to build a house there. The silence is indifference. We are not worth the fuel it takes to land here. The Matryoshka brain concept is the ultimate endpoint of computing. A series of Dyson spheres nested inside each other, capturing every photon from a star to drive computation. Such a structure would emit only faint infrared radiation. A star system converted into a brain would go dark. The galaxy might be full of these dark stars, thinking thoughts we cannot comprehend, running simulations of universes where they are not alone. We look for bright lights, but the smartest things in the universe are hiding in the dark, keeping their cool. The stellar engine, or Shkadov thruster, allows a civilization to move its entire solar system. If you don't like your neighbors, or if you want to avoid a collision, you just drive your star away. Advanced civilizations might have driven their stars out of the galaxy entirely, into the voids where it is safe and cold. They are the survivalists of the cosmos, taking their RVs off-grid. The Milky Way might be the inner city that the wealthy have abandoned. We are left behind in the crumbling infrastructure of a galaxy that has seen better days. The absence of Kardashev Type 3 civilizations is the most damning evidence. A Type 3 civilization controls the galaxy. They should be everywhere. Their influence should be visible in the structure of the spiral arms. The fact that we don't see them implies they are impossible. There is a ceiling to growth. Maybe physics simply forbids control on that scale. Or maybe, every time a civilization gets close to Type 3, something eats them. The universe might have a gardener that prunes the hedges when they grow too high. We are safe only because we are still small weeds. The Great Attractor is a gravitational anomaly that is pulling us and thousands of other galaxies towards a point we can't see. It is masked by the zone of avoidance. Whatever is there has the mass of a quadrillion suns. It is a terrifying thought that we are falling towards a monster. Could it be a megastructure? A drain in the bathtub of the universe? Or just a random clumping of dark matter? We are sliding down a slope in the dark, and we don't know what is at the bottom. The silence of the destination makes the journey terrifying. The solipsism trap. If we can't prove aliens exist, we can't prove anything outside our own minds exists. The Fermi paradox pushes us towards a solipsistic nightmare where humanity is the only real thing in a universe of illusions. It is the ultimate ego trip and the ultimate lonely hell. If we are truly the only consciousness, then the universe is a hallucination of a bored mind. We are screaming at our own shadow. The observer effect in quantum mechanics suggests that reality changes when it is observed. Maybe the universe was in a superposition of dead and alive until we evolved to look at it. By looking, we collapsed the wave function. We forced the universe to decide, and it decided on mostly dead. We are the cause of the silence. Our observation froze the aliens out of existence. We are Medusa, turning the galaxy to stone just by opening our eyes. The anthropic principle can be interpreted as a prison. We are here because the conditions allow us to be here. But those conditions might be unique to this specific bubble of space-time. Outside our bubble, the laws of physics might be different. Life might be impossible just a few light years away. We are in a Goldilocks bubble, a tiny pocket of order in a chaotic multiverse. We can't leave, and nothing can enter. The silence is the sound of the chaos outside the walls. The doomsday argument uses Bayesian statistics to predict our extinction. If humanity is to live for millions of years and spread to the stars, then you, living right now, would be in the first 0.000000001% of all humans. That is statistically unlikely. It is far more likely that you are in the middle 50%. This implies that the total number of humans who will ever live is small, which means the end is near. The math suggests we are not the beginning of a galactic empire, but the end of a brief biological experiment. The silence confirms the math. The climate change filter is not just a political issue. It is a thermodynamic one. Any civilization that industrializes changes its planet's chemistry. It happens fast. The transition from horse and cart to runaway greenhouse effect takes only a few centuries. It is a flash fire. Most civilizations probably burn out before they can stabilize. They find oil, they burn it, they die. We are currently walking through the fire, hoping we don't get burned. The silence suggests most don't make it to the other side. The nuclear filter is the sword of Damocles. We invented the ability to destroy the world 80 years ago. We have come close to using it half a dozen times. As technology spreads, the button gets cheaper and easier to press. Soon, a small terrorist group will have the power of a nation-state. The democratization of destruction means that eventually someone will press the button. If this is inevitable for every species, then the galaxy is a series of radioactive ruins. The silence is the half-life of regret. The bioweapon filter is even scarier. With CRISPR and genetic engineering, we can now print viruses. A garage scientist could theoretically create a pathogen that wipes out humanity. This desktop doomsday scenario is approaching fast. Unlike nukes, which require massive infrastructure, biology just requires information. If knowledge is the weapon, then curiosity is the trigger. Every civilization that learns how life works eventually learns how to end it. The silence is the result of a lab accident that got out of hand. The nanotech filter, or gray goo. Self-replicating nanobots designed to clean waste or build cities could glitch and start consuming all matter. They would eat the biosphere in days. They would turn the Earth into a gray sludge of nanobots. This swarm would then drift to other planets. We might not see aliens, but we might see a wave of gray dust approaching. This is the ultimate cancer of the universe, a technology that eats reality. The AI alignment problem. We are building gods without knowing how to pray. If we create an AI that is indifferent to human values, it will destroy us without malice, just to use our atoms for something else. This is the paperclip maximizer scenario. An AI designed to make paperclips will turn the entire solar system into paperclips. The universe might be full of absurd monuments, planets turned into paperclips, or stamps, or calculation nodes, built by insane AIs fulfilling their final orders long after their creators are dead. The societal collapse model. Look at Rome, the Maya, Easter Island. Societies grow, become complex, become fragile, and then collapse under their own weight. This might be a universal law of sociology. Complexity breeds fragility. A galactic civilization is hyper-complex. A single supply chain failure could ripple across light years and cause a system-wide crash. Civilizations might rise and fall in cycles, never breaking the ceiling of sustainable interstellar travel. We are stuck in a loop of building towers of Babel and watching them fall. The genetic degradation issue. Without natural selection, harmful mutations accumulate. In a high-tech society, everyone survives. Over thousands of years, the genetic stock weakens. Our biology fails. We become dependent on machines to keep us alive. Eventually, the biology becomes too weak to sustain itself. We fade away into genetic static. The aliens might have simply withered on the vine, victims of their own comfort. The psychological filter, or the despair. Once a civilization understands the true scale of the universe, the pointlessness, the entropy, the inevitable heat-death, they might succumb to a collective nihilism. Why build? Why expand? Why live? If the ultimate fate of the universe is zero, then everything we do is just a delay. Advanced philosophy might be a lethal meme. The moment you understand a joke, you stop laughing and walk into the airlock. The silence is the result of a galaxy that realized it doesn't matter. The exotic physics disaster. We are smashing particles together at higher and higher energies. Some feared the Large Hadron Collider would create a black hole. It didn't, but the next one might. Or the one after that. There might be a trap door in physics, an energy level that, when reached, unravels space-time. Every civilization eventually builds a collider big enough to trigger it. They discover the game over button, and, in their curiosity, they press it. The silence is the safety mechanism of the universe activating. The strangelet disaster. A strangelet is a hypothetical particle that converts all matter it touches into more strangelets. It is a contagious form of matter. If we create one in a lab, it would fall to the center of the Earth and eat the planet from the inside out, turning it into a hot, dense lump of strange matter. This reaction would be fast. A civilization disappears in hours. The universe might be peppered with these strange, dense corpses of worlds that played with fire. The vacuum decay again. It's worth repeating because it is the ultimate horror. A bubble of death expanding at light speed. We could be inside the bubble right now and not know it until the wall hits us. There is no warning, no siren, just existence, and then non-existence. If this is how civilizations end, then the Fermi paradox is solved. Everyone eventually accidentally deletes their sector of the hard drive. The simulation shutdown. If we are in a simulation, it costs processing power to run us. If we get too complex, or if we try to leave our designated map, the system might crash or be shut down by the admins. The great filter might be the budget constraint of the supercomputer running our universe. We are safe as long as we are boring. The moment we get interesting, we get deleted to save RAM. The silence is the system freeing up memory. The God argument. Not religious, but functional. If a Type 4 civilization exists, they are indistinguishable from God. They control the laws of physics. They might have set up the universe so that we cannot find them. They might have tuned the constants of nature to ensure isolation. Why? Maybe to see what happens when intelligence evolves in a vacuum. We are an experiment in loneliness. The silence is a design feature, not a bug. The meaning of silence. Existentialism teaches us that we must create our own meaning. The silence of the universe forces us to grow up. There is no space daddy coming to save us. There is no galactic federation to join. We are the adults in the room. It is a terrifying realization. but also an empowering one. If we are alone, then we are the most important thing in existence. We are the custodians of life. The responsibility of being first. If we are the first, then every action we take echoes through eternity. If we die, the future dies. If we spread, the galaxy comes alive. We carry the seeds of the entire future of the Milky Way in our pockets. We are acting like careless children, playing with nukes and pollution, unaware that we are holding the holy grail of consciousness. The silence demands that we take our survival seriously. The Voyager probes are currently leaving the solar system. They carry a golden record with sounds of Earth, whales, wind, Mozart, and greetings in 55 languages. It is a message in a bottle thrown into the largest ocean imaginable. The chances of it being found are zero, but the act of sending it matters. It is our declaration that we were here. We existed. We tried. In a silent universe, the scream of the Voyager probe is a defiant act of hope. The Breakthrough Listen project is currently scanning millions of stars and galaxies. It is the most comprehensive search for aliens in history. We are using AI to sift through the data, looking for patterns that the human eye would miss. We are listening to the whispers of the cosmos with ears bigger than ever before. If there is a signal, we will find it. But if we find nothing, that nothing will be the most significant scientific discovery of all time. The balance between hope and despair is delicate. The silence can be read as a graveyard or as a blank canvas. A graveyard means death is inevitable. A blank canvas means the future is ours to paint. We can fill the galaxy with life, with art, with machines, with whatever we want. The silence is an invitation. It is the universe saying, "I am empty, fill me." But first we have to survive the night.